Hey guys, Ms. Davis here. Unit 7, Skill 6 is in this video. So writing equations of lines. Write down your essential question. How do I write the equation of a line that's parallel or perpendicular to another line? Okay, so write that down, and what we're going to be doing today is writing equations of lines, and we're going to use a specific formula that is called the point-slope formula or equation. And it's right here. It's very important. We have to have this memorized as well. And m in the formula is going to be the given, or not the given, but the slope that you need, and x1, y1 is going to be any given point that that line passes through. Okay, so as you can see, we've got some negatives in our formula, so the two negatives there means we're going to use the opposite signs whenever we plug in our points, and you'll see that they're going to change. So it's just like that circle center formula. When we have negatives in the equation, the signs will change. Okay, so let's go through an example and use our new formula to solve and write equations. So example number 1 says we're going to do parallel through a point. Okay, so parallel lines are like that. And so those are not exactly parallel, but if they're parallel through a point, then that means that their slopes need to be exactly the same because they have the same increasing or decreasing rate of change. Okay, so write the equation of a line that passes through the point. So here's our x1, y1. Whoa, that's not what I wanted. x1, y1 that is parallel. So if it's parallel, we need the same m, or the same slope. Okay, those are quotation marks. To the line whose equation is this, 2x minus 3y. Okay, so step 1, we always have to identify the slope by getting it into y equals mx plus b form. So I have to rewrite my equation, rearrange it, so 2x minus 3y equals 11. We're going to get it in y equals mx plus b form. So I'm going to subtract 2x from both sides, bring down the negative 3y equals 11 minus 2x, divide both sides by negative 3, okay, and then we get y is equal to so 11 over negative 3 we can leave as a fraction, but right in here when we have two negatives stacked up on top of each other, a negative divided by a negative is going to change into a positive, so plus 2/3 x. Okay, so now we have to identify which one is the slope, which one is the y-intercept. So the slope is always, always, always the one that's attached to the x. So our slope is 2/3. Okay, so our second step is the parallel m, or that's going to stand for the parallel slope, is a positive 2/3. Okay, so we need the slope for this one. If it was perpendicular, it would be a different thing, but we haven't gotten there yet. Step 3 after that is going to be take our information and plug it back into our general formula. So our equation of our line, we're going to start with y minus y1 equals m parentheses x minus x1. Okay, so I'm just going to copy that down from up above. And now what we take is our point, which is the x1, y1, and we use our parallel slope of positive 2/3 and plug them in. Okay, so x and y, the regular x and y, are always just going to stay x and y. So, oopsies. So let me get out a highlighter tool here. Okay, so we get y minus, our y1 is negative 5, so it'll be a negative 5. So see how there's two negatives in there. There was a minus from the original equation with the negative from the point equals, our m value was positive 2/3. Parentheses, x stays the same, minus our x1 is 6. Okay, so we could rewrite this as y plus 5 equals 2/3 parentheses x minus 6. Okay, so that is the answer if it does not tell us to get it in y equals, or if our answer options are not in y equals. So this is in point slope form, but then sometimes our multiple choice might be in y equals mx plus b. So if that happens, we just have to go through and distribute the 2/3. So I would go through and distribute that, and when I do, we would get y plus 5 equals 2/3 x, and then when you multiply, it would be 2 times negative 6 is negative 12, divided by 3, which would give us a negative 4. Okay, and then to get it in y equals, we would just have to subtract that 5 from both sides, and we would end up with y equals 2/3 x minus 9. Okay, so here's our equation in y equals. These are exactly the same, but this one is in point slope form, whereas this one is in y equals mx plus b. Okay, so let's go ahead and just come up with some general steps on the side here. So our steps, step 1 that we did here was to get our equation in y equals mx plus b. So step 1, get into, y equals mx plus b. Okay, then step 2, we had down here, we had to identify the new slope that we needed. So identify slope. So m is going to equal the same if parallel, and m is going to equal the opposite reciprocal if perpendicular. Okay, and we'll get into another example with that if you're not positive on how to do that yet. Step 3 that we did was over here. So step 3 is to plug your slope, which is m, and your point, x1, y1, into point slope formula. Okay, and then our last step, which was step 4 right here, is to get into y equals if you need to. Okay, so step 4 is to get into y equals mx plus b if needed. You don't always need it. Again, you could have just left your equation as this right here. This would have been full credit if it was free response. Okay, so that's that for parallel. Now we're going to do an example number 2 that is perpendicular through a given point. So here we go. Example 2, perpendicular through a given point. Which of the following is an equation of a line who goes through the point 3, 5? So there's our point that it goes through. So that's x1, y1. And is perpendicular to y plus 8 equals 2x. Okay, so perpendicular slopes are opposite reciprocals, so that means we're going to flip and negate. So opposite reciprocal slopes. Okay, so step 1, let's follow our steps. We're going to get our equation in y equals mx plus b. So y plus 8 equals 2x. We're going to go ahead and subtract 8 and get y equals 2x minus 8. Okay, identifying our slope as the number attached to x. So our next step is going to be finding our perpendicular slope. So I have an original slope of 2 over 1, and I want to flip it. So I'm going to change it to 1/2, and it was positive. Now I'm going to change it to negative. So our new slope is negative 1/2 as the perpendicular slope. Okay. Then step 3, we're going to plug it back into the y minus y1 formula. So let's just write it down really quick. Equals m parentheses x minus x1. Okay, so the things that we need in order to do that was our new slope of negative 1/2 and our points of 3, 5. They're both positive, so when we plug them both in, they're both going to turn negative. So I'm going to do y minus, our y1 is 5, equals negative 1/2 is our m, parentheses x minus 3. And if we pause there, look at our options. Our options are all in point slope form, which is fabulous. That means we don't have to get it in y equals, which means that C is the correct answer. Okay, so once again, just make a quick note that these are all in point slope form, So y equals mx plus b, not needed. Okay? All right, next page. Let's keep chugging. All right, example number 3, we're going to use a graph. So it says, write the equation of a line. As soon as we see that, we should know we need to use y minus y1 equals m parentheses x minus x1. If they give us this point, x1, y1, okay, it passes through the point 2, 5 and is parallel to the given line. So if they don't give us an equation, we need to find find the slope from the graph. Okay, so we need to find two friendly points that lie perfectly on the line. So I see one here, I see one there, I see one there. So you see how there's the trend of those nice friendly points? And then we have to find the slope. So step 1, we need to find the parallel m is equal to up 1 over 2, up 1 over 2, up 1 over 2. You guys see the steps that you're climbing there? So it's a positive 1 over 2 is the slope. And if it's parallel, then we keep it the same. Step 2, we need to now plug back in to our formula. So we've got our y minus y1. We're going to use that same formula for step 2 and just plug in what we know. So we've got our slope as positive 1/2 and our x1, y1. So those are the only two things you need in order to plug into this formula, the point and the slope, hence why it's called point-slope formula. Okay, so we've got y minus, our y1 value is 5 equals positive 1/2 is our m, parentheses x minus 2. Okay, so that's it. That's our final answer. If it's open-ended free response, this is full credit. You're good to go. That's a check mark. Woo. So it's good to go. That's full credit. But again, that's in point-slope formula. If we needed to get it into y equals mx plus b, let's just practice that one more time. Step 3, we would go ahead and distribute that 1/2, and we would write y minus 5 equals 1/2 x. 1/2 of negative 2 is negative 1, and then add the 5 to both sides, canceling out the 5s, getting y equals 1/2 x, and then that gives us a plus 4. Okay, so those again are exactly the same equation, just two different formats. But this one would have been just fine if it was free response. This one you might need for multiple choice. Okay, next one down says write the equation of a line that passes through the point 2, negative 2, so there's our point y, x1, y1, and is perpendicular to the given line. Okay, so now our first step, if we don't have an equation, is to find the slope from the graph. So I've got to find some friendly points. I've got one there, let's see, I've got another one down here. I've got another one up over here, okay, and then one right there. So there's some nice friendly points. And if we track the rise over run, we've got down 1 over 3, down 1 over 3, down 1 over 3. So it's a slope of negative 1 over 3. And just remember that we're always looking to see is it uphill or downhill. So our perpendicular slope is either positive or negative. So in this case, it's a downhill slope, so it's a negative 1/3. And we need to flip and negate it. So I'm going to switch it to positive 3 over 1, which 3 divided by 1 is just positive 3. So our m value is going to be 3. So m equals 3. Okay, that's our perpendicular. Again, we need to flip and negate. Okay. Then step 2, let's plug into our formula. So y minus y1 is a negative 2, so we'll have double negatives there, equals our m, and again we're using that point there. So our slope is 3, x minus our x1 value is 2. Okay, so that would be full credit if it was free response, but step 3, actually we probably should rewrite this as plus. So y plus 2 equals 3 parentheses x minus 2. Okay, so technically that should be it. But if we wanted to get it into y equals, it would be y plus 2 equals, distribute the 3, would be 3x minus 6, and then subtract 2 from both sides, and it would be y equals 3x minus 8. Okay, so those again are the same, but two different forms. So go on to the next page. We have one last page. Okay, example 14, it's been copy and pasted right from a Regents exam if you can't tell by the difference in font. But example number 14 says, which is really our example 4, in diagram below, triangle ABC has the 3 vertices here. They plotted the points for you. What is the slope of the altitude drawn from A to BC? Okay, so I just want to make a quick note over here because we haven't talked a ton about altitude yet. So definition is the perpendicular height from the vertex, so from the angle to the opposite side. So for instance, if I were to draw out a triangle here like this, then if I named it triangle ABC, then the altitude would be, if I connected it from B to the opposite side, it just has to be perpendicular. So there's that key there. So we're looking for a perpendicular line that would be drawn. So in this case, we're drawing from A to side BC. So our altitude is going to be here from A to the opposite side, and it's going to be creating that 90-degree angle. So what we want to do first is we want to find the slope of our original line segment that we want it perpendicular to. So step 1 is we want to find the slope, M is always the slope, of BC. Okay, so the slope, I'm just going to write slope under there, of BC, if I look from left to right, it's definitely a positive slope. So between positive and negative, it's positive. And we're going up 2 over 5. Okay, so the positive slope would be positive 2 over 5. And then step 2, if we want the perpendicular slope for the altitude, so the altitude again needs to be opposite reciprocals. Whoa. We would take that 2 over 5, flip, and negate it. So we would take the 2/5, flip it around, make it 5 over 2, and change it from positive to negative. So our perpendicular altitude, that would be drawn in red there, would have a negative 5 over 2 slope. Okay? All right. If it said they wanted the line parallel to BC, or if they wanted to find a parallel line to BC, then you would be finding and keeping the same slope of 2/5. But for this one, we wanted perpendicular, so we had to use opposite reciprocal slopes. Okay? All right. Go ahead and rate a quick summary and start your practice.